Ladies and gentlemen, good morning. Thank you so much for hanging out with us this morning on what's officially day 2, but for me, it's day 1 of DataMark's virtual conference. This is our 2nd annual virtual public safety conference. Guys, you helped make this such a great success last year. We had to come back another year and bring you some amazing content. Before we get into our keynote for the day, I want to go over some house cleaning. I want to remind everyone that all of the sessions that you will be attending throughout the next 3 or 4 days will be recorded for playback. So all of the content will be posted to our YouTube page so that you can check it out again later, just in case you missed something. Guys, also, throughout this keynote, and I want to say throughout all of our presenters over the next 3 days, we really want to encourage engagement. So as you guys have questions, if you have comments, if something's just bugging you, you want to get it off your mind, please put it in the Q&A tab or the chat window. We'll make sure we get to it if we have time. And I've already spoken to Keith. Throw your questions in as you have them. If we're able to address your questions during Keith's presentation, we'll take it. If not, we'll reserve questions till the end. This is going to be very fluid. It's going to be a lot of fun. Guys, I hope you got your coffee. Grab a hold of your seat because Keith is such a great speaker. I've listened to Keith several times. I love the content and the perspective that he brings to any conversation. And I'm super excited to have Keith as our keynote this morning. So guys, you're in for a good one. And with that, I'm going to turn it over to my good friend, Keith Masbeck with Plum Run LLC to take us away this morning and get started. So Keith, welcome. We really appreciate you being here, man. You're muted, Keith. Virtually, they got you. First thing in the morning.
Man, it's too early. All right, let's try this again. Thank you so much, Drew. I really appreciate the opportunity to speak with this super important audience. I've spent 30 years of my career in the national security space, and there's no question through my lens that the first responder community, the entire infrastructure that enables that is part of that entire community. And if we didn't believe it before 9/11, right, we certainly understood that afterwards. That it is whether we are preparing to operate overseas, preparing for things like disaster mitigation, disaster response here at home, natural disasters, acts of terror, what have you. It really is all one team, and it all functions best when it's as one team. So. What I've promised today with the title of this presentation is that I would talk a little bit about geospatial intelligence and do a primer on what it is and why people in this community should care. It's a topic about which I have a great deal of passion and have spent a lot of my time professionally working on. And so I'm excited to do that. And again, as Drew said, I'm super interested in making sure that over this little period of time we get to spend together this morning, that it's interactive, and that please ask your questions, drop in comments, let me know if you disagree with something. Happy to mix it up and have those discussions. I am a student of history, in addition to being someone who's a geospatial intelligence practitioner and before that, sort of an all-source intelligence professional, an infantry officer. But long before any of that, I was certainly interested in history and political science. So actually, on this day, April 13th in 1960, the United States launched a system called Transit, which was sort of the first navigational satellite system launched by the US. We were all relatively familiar with GPS in the most modern context, but Transit starts with a Doppler shift capability on April 13th, 1960. So I think it's incredibly appropriate that we should be having this discussion today, given that tie to history. I couldn't help but notice also, as I looked back in history on April 13th, interesting, as some of you may know, this is the day, in fact, that aboard Apollo 13, that the oxygen tank exploded, and the anomaly that they had that caused a pretty grave situation on that space mission, which has been memorialized right in books and fantastic movies about it. And if you're not familiar with the story, I certainly commend it to you because it's inspiring and pretty phenomenal, thinking about the technology that they had at the time, the ingenuity, the teamwork that was required to get them back safely. So it's a great story, and I commend it to you. So now let's talk about geospatial intelligence. What is this thing I speak of? Well, I'm going to define it. The term was sort of made up, quite frankly, in around 19. Well, I'm sorry, it was about 2003 when the National Imagery and Mapping Agency had been created at the end of 1995, beginning in 1996. And it was a bit of a shotgun marriage between the Defense Department and intelligence community, the mapping establishment, largely represented by the Defense Mapping Agency, and the intelligence imagery analysis community that was the bulk of which was in something called the National Photographic Interpretation Center, or NPIC, which was an organization that existed under the CIA. So this National Imagery and Mapping Agency was pulled together. All or part of about 13 different organizations contributed into it to pull together the idea that that we kind of take for granted now, right? That imagery and mapping had this very important connectivity, and that if we put them together, it would be 1 + 1 would equal 10 in terms of our capability and our ability to manage that. Fast forward, that shotgun marriage remained sort of contentious. I was at the scene of the crime, if you will, at the creation of the National Imagery and Mapping Agency, or NEMA. We, under the direction of then retired Lieutenant General Jim Clapper, later the Director of National Intelligence. He was the director of NEMA, and found that every day he drove through the gate and he saw that this agency was still called the National Imagery and Mapping Agency. So even in the name of the agency, it was two different things. And so we thought, how are we going to get people to rally around a new idea? And through some iterations, essentially, we made up the term geospatial intelligence. We needed to get mapping out of the name so that the DMA people, the Defense Mapping Agency people, couldn't sort of hold on to the past. We needed to get imagery out of the name. So the National Photographic Interpretation Center folks, the imagery people, couldn't hold on to their past. And we said, why don't we rally around a new idea going forward, this idea of geospatial intelligence. So, right, the intelligence brought the imagery along, the geospatial brought the mapping along. And very importantly at the time, there was some hurt feelings about the fact that this thing called NEMA was 4 letters. All the more grown-up agencies like NSA and CIA were only 3-letter agencies. And so there was a desire to fix that as well. So as I sometimes say, we traded the divisive ampersand in Imagery and Mapping Agency for a magic hyphen, because it's that magic hyphen. If you believe in the Easter Bunny and Santa Claus, then you can be okay with this hyphen, making the National Geospatial Intelligence Agency 3 letters, or what is known today as NGA. So that is the derivation of some of the history of geospatial intelligence, a term that was made up and then codified into a bill in Congress, signed into law by the President in the National Defense Authorization Act for fiscal year 2004. So what is it? There is a legal definition that the National Geospatial Intelligence Agency is required to use. I like to think of it a little bit differently. I am not bound personally by the law as it relates to what NGA is supposed to do. That law was created and defined, both the NDAA that created NEMA and then NGA, as bureaucratic compromises in terms of who would do what within the national security establishment. So it was limited for certain reasons. For instance, at the beginning of NEMA, handheld photography was specifically left out of the definition because that belonged to CIA and to the Defense Intelligence Agency. Both did some of that and didn't actually want to give that up bureaucratically from a mission perspective into this new agency. So those were bureaucratic compromises that were made, and you will find legal definitions in doctrine and doctrinal terms in the Defense Department and the intelligence community. I'm going to propose we think about it a little differently. So I believe it's the intersection of four things. So it's remote sensing, from phones to drones to space, anything that is bringing in data about activity, and bringing that in again remotely from mud to space. The second is geospatial and location data and information of all types and layers. So this can be the seafloor, this can be bathymetry data, right, associated with that. This could be in the littoral. This can be physical geography. This could be political geography and boundaries and so forth. This could be human geography, which encompasses history and religion and culture, right? So you're starting to get the idea, and many of you have some tie, I imagine, to geospatial data and information, or you might not be on this Zoom today, or working with DataMark. So you can see that I'm sort of describing all the layers that one could think about in that stack, if I may. The third piece of this is data analytics. So what do I do with that remotely sensed information? What do I do with that geospatial and location data and information, and how do I make sense of it? So often throughout our history, there's been this desire for more. Well, if I just had more data, I could do better. If I had more data, I could serve my customers better. But we didn't really, for a long time, have the ability to manage it. And when more is just sort of just shoveling more coal on the pile, but no ability to do anything with it, it actually can become a distractor. It can become overwhelming. And I'll talk about some of the enabling technologies that we have now that are actually making more is helpful when you can manage it and do something with it. And with, as I'll mention in a few minutes, with advanced data analytics techniques, more is indeed valuable because we can get through it in time. And we'll talk about that a little bit as well. So the fourth piece of this is data visualization, the ability to present this in a way at the time and place that enables someone to make a decision or take action, right? Doing all those things, having elegant remote sensing tied to brilliant geospatial data and having that all that analyzed towards some end to help somebody get to an answer. If it's not presented to them in a way that they can intuitively understand and appreciate and incorporate into their decision cycle, if they're not able to take advantage of it at the point of decision, at the point of action, then all the rest of it was really an interesting academic exercise, right? It wasn't helpful. So it's as we talk about in the intelligence community, the best intelligence delivered too late is worthless. And we often talk about analysis paralysis in the intelligence community. We talk about wanting to know, just if I just had one more piece of this puzzle, I could get it right for the person, the customer, the person I'm serving. But we have to be mindful of their timelines. And those of you, again, who work in the first responder community understand that it is all about timelines and the golden hour and getting there in time and being able to decision enable and action enable the people you serve, where you are in the position of having to take in data and information, whether that's on a 911 call or in other ways in a command center or what have you, and then be able to turn that into something that people who have to go to the scene, the people that have to go take action, the people who have to react to something, have the best intelligence, really, the best at that point of knowledge that to manage the situation at hand. And the better we enable them, the better they can do, the better they can apply their skills, the better they can apply the equipment they have to the problem at hand, the better they can anticipate, then they can be out in front of things. And we always want to enable people to be acting instead of reacting, to be anticipatory where possible. So again, just to quickly review, right? Geospatial intelligence, the intersection of remote sensing, phones to drones to space, location geospatial and location data and information of all types and layers, data analytics and data visualization. All that put together towards some end. As I talk about geospatial intelligence, now you have sort of a reference. There are critical enabling technologies for this idea of geospatial intelligence. And frankly, while many of us had a vision over time of what this could be, of the type of the power that we could accrue by being able to pull all this together, we were frustrated by large, and I'll date myself here, but if we think about, 9.6 dial-ups, right? And wanting to transmit, I remember wanting to transmit a picture, of my son to my parents, and kind of hitting send on the internet in the evening and hoping that it had transmitted by the morning. But of course it hadn't, because there'd been some sort of blip overnight and I had to start again. But we were frustrated by large file sizes, by slower inability to process it in a timely manner, the expense of storing it, the inability to move it because of a lack of broadband, and look, some of those things still exist today in many parts of the world, and in fact, certain parts of the United States, to be sure. But at the macro level, I'm going to talk about a number of enabling technologies right now that have all sort of come together to take this concept of geospatial intelligence and make it applicable to a broad range of problems. Now, look, I come from a background of national security, and so it's very native for me to talk about this in the intelligence community sense, in the Defense Department sense, even in the sense of through the lens of DHS. But as I mentioned at the beginning, this is certainly alive and well in the first responder community. And in fact, geospatial intelligence, I argue, is disrupting every vertical sector in our economy. And things like autonomous vehicles don't happen without geospatial intelligence, and smart cities don't happen without geospatial intelligence. And digital twins that are part of smart cities that enable smart grids and smart infrastructure. All of this is related to an underpinning of geospatial intelligence to create and maintain and to make effective and efficient. And think about the things that you do, the apps that you use that are enabled by precision location data and so forth. So one of my games I like to play, and I'm happy to play it today through the chat or Q&A function enabled by Drew, is look, throw out something, and I think I can articulate why it's and how it's being disrupted and enabled by geospatial intelligence. So let's talk about some of these enabling technologies. One is precision geolocation data. I talked about this satellite being launched in 1960, the transit system. Now, we know about precision navigation and timing enabled by GPS, the global positioning system, right? There are other systems as well. The Russians have a system, the Europeans have a system, the Chinese have a system, and so forth. So there is more than just GPS. That's the US system. But we are all enabled, and we are all carrying around precision geolocation receivers in our mobile devices, most of us in our vehicles now. So we are precision geolocation enabled, and then there are certainly tremendous opportunities associated with that, right? And we know that it gets us to a doctor's appointment at a building we've not been to before. It enables the type of things we're trying to do with next gen 911 and the underpinning of FirstNet. So we understand there's lots of good, but there's an ethical discussion to be had around the fact that we are all broadcasting our location, and that location is known and shared, and in some cases is sold by app providers and by mobile providers. And so there's another side to this, and happy to talk to some of that as well. But we are in an era of near ubiquitous precision geolocation. On the remote sensing front, the capabilities that were in the hands of a few governments only, just maybe 2 decades ago, are now absolutely available to anybody with a checkbook. And in the case of things like Google Earth and so forth, it's readily available on the internet for you to see. And that's, Google Earth is an amalgamation of whatever data Google can find to populate in there, whether it's airborne data or data from satellites. They're going to put the best that they can find based on what they're willing to spend to assemble the quilt of the globe, as well as the ground collected data, right, that enables Street View. So remotely sensed information has never been more available. We've got increasingly cheaper access to space, miniaturization of technology, the ability, earlier this year, I think a record launch of 143 satellites on one spacecraft out of India. If I have that number, I think I'm close on that number, but you can check me on it. In any event, the ability of remote sensing companies like Planet to put up tremendous constellations that now have us talking about the complementary value of spatial resolution as well as temporal resolution. So what's the value of being able to see something very clearly? A company like Maxar that has the highest resolution imaging satellites, in commercial imaging satellites in the world. Airbus, not too far behind them out of Europe, Maxar, a US company. But then a company like Planet and a company coming on like Black Sky that are managing to have very large constellations that are allowing you to see things more often. And so understanding the complementary nature of that. Other phenomenologies like synthetic aperture radar that allows you to see at night and through clouds, that's an active sensor. Many of you might be familiar with LiDAR, so that's photons, light detection and ranging from aircraft now, and soon increasingly we'll see that ability from space. We're seeing weather sensors, highly precise weather sensors combined with weather analytics, radio occultation, which is beginning to give us a better measurement of what's going on in the atmosphere. So we're really seeing an interesting advances in remote sensing. So we've got that ubiquitous geolocation. We've added the remote sensing, got very powerful software at any number of companies now. It allows customers to take a hybrid approach and not be locked into a proprietary solution, but they really can look at cobbling together what is the best solution for them in their needs. So there are open source solutions, there are proprietary, very powerful proprietary solutions as well, but that marketplace is really beginning to open up and create options for people. Processing power continues to grow. It's sort of in some ways keeping up with Moore's law. Some are arguing perhaps that the curve is flattening a little. I think the most important advance with respect to geospatial intelligence has been the application of GPUs, graphical processing units. These processors that were invented primarily for video gaming and other applications now used in data analytics, now applied to things in the geospatial and imaging realm. Very, very powerful in their ability to chunk through things very quickly. So you start to see the additive effect of all these things. Storage, right, getting cheaper and cheaper. You think about the storage capacity we have on a thumb drive now. And again, those of you of a certain age remember what it costs to store files, even the ability to store large files in the past. And of course, the advent of cloud computing and the cloud analytics that go with it. So you don't have to own a GPU, but rather you can spin up GPU instances in the cloud and have your data stored there and process your data there and bring down the information that you need at the time and place you need it. Talked earlier about the growing ability to access broadband, certainly within the context of the first responder community. The advent of FirstNet and the making sure that there's a wireless network that provides assured connectivity for first responders. But as broadband proliferates, and now with SpaceX launching Starlink, the idea of beginning to have ubiquitous global coverage for communications from space by their proliferated low Earth orbiting communication system, begins to change the entire backbone infrastructure as we've known it to date. Talked a little bit previously about advanced analytics, machine learning that leads to artificial intelligence, computer vision, allowing the machines to do that which they do well, enabling humans to do the things that we do well. All right, and that is, it's sort of one way to talk about that is to think that, yes, we know that a machine can beat a human in a chess match. A human paired with a machine beats a machine and beats a human in a chess match, right? So when we are understanding how that all comes together, we have a lot to do on the human machine, human computer interface, and who does what, where, and when, which accrues to which. And as the machines get smarter, as they are more enabled, as they are able to learn in a machine learning environment, we can offload things from the human, the mundane tasks from the human to the machine, and allow those things that require judgment and experience largely remain in the realm of the humans. Talked about computer vision, increasingly allowing this modeling and labeling so that security cameras can see things, so that we can see things from other remote sensing platforms, and the computer can identify them, that they have a model, that they have been trained, and that they can learn over time. Again, enabling us to move more quickly. The Internet of Things is a massive geospatial intelligence opportunity, right? Because these things, the Internet of Things, these things are somewhere. And because they are in situ, because they are in a place, some of them, of course, are moving, but those that are, but they are still moving from a place to a place along a route, which is a place. But the Internet of Things creates a tremendous amount of opportunity and rich data and information into this system when we are trying to understand things, instrumenting buildings to tell us more about what is happening at a scene before we even get there, understanding that a building can tell us much more than it currently does in terms of maybe, there's an alarm on a certain floor. A fully instrumented building can be much more precise than that in terms of specific temperature and specific location and specific impacts to other parts of the building. And then the final technology that I'll mention today is, augmented reality, virtual reality. So sometimes AR and VR are slammed together and put under a broader context of XR. This is important too, because this is where synthetic environments roll over, and synthetic environments are connected to real environments, and we are able to train and rehearse and act on common data sets. We're able to put people in situations to practice, to rehearse, to practice interoperability. Even when they are in different locations, we can put them together virtually and allow them to walk through things, to allow them to develop tactics, techniques, and procedures. Whether, again, it's responding to the aftermath of a hurricane, whether it's responding to the aftermath of a terror attack, responding to an active shooter situation, or doing something overseas in a military context, there's tremendous value developing in this XR, these different versions of reality on these stacked data sets. So with that, I've now sort of covered the idea of what's geospatial intelligence, what are the enabling technologies. I've tried to sprinkle in there some notion of sort of, to the title of my talk, why do you care? Why does it matter? Well, certainly, I've touched on a few examples. We talk about the idea of next gen 911 that really gets to providing the ability for a dispatcher to develop an intelligence picture and share it out with the people who are en route to a scene, who are at a scene. And when they're at the scene, to be able to collect data and information back, further assemble that intelligence picture, to disseminate that to follow-on responders, to disseminate that in terms of alerting local medical facilities with respect to mass casualties, being able to understand how long it will take them to people to arrive at the scene, how long it will take for them to evacuate people from the scene and get to the hospital. So this geospatial enabled next-gen 911, right, is this shared vision that I think we all have for how we can get at this. And of course, we're all frustrated with the challenges, the underlying challenges of national addressing databases and being able to pull together common addressing. So some of the basics, and I'm going to talk in a little bit about some of these things as well that get to things like standards and interoperability. I touched on FirstNet a little bit, the idea of creating a reliable wireless communications network for first responders, understanding that they can't be competing at the time of crisis. They can't be competing with everyone else who wants to be on a network, but rather having the bandwidth, having the assured communications. Because as I learned as an intelligence professional in the Army, I also had to be sort of a semi-professional communications officer, because no matter what we did as intelligence professionals, if, per my earlier comments, if we couldn't get it to the people who needed it in time to make a decision, then there was no way for us to do so. There was no way for us to really support them fully. And so you've got to be able to get it there. And that is the idea of FirstNet, is this underlying wireless network that takes the intelligence work that is done in the context of next-gen 911 and allows it to be disseminated, right? So and to have it go two ways. So all that's got to come together. I'll touch now on this idea of standards and interoperability. It is so critically important in this discussion. It's another thing, people don't like to talk about data. They don't like to talk about metadata. They don't like to talk about standards. As I like to say, we all agree standards are important. That's why we all have our own, right? So it's hard to come together and find standards creating bodies in this world. The Open Geospatial Consortium is one of them. But this is really truly where companies and governments and organizations come together to manage standards and interoperability, because it's not the time to find out at the point of crisis that our radios and municipalities can't talk to one another, or that we can't transmit data to one another. We can't have a shared situational awareness with one another. And we've made tremendous advances in that in the national security world and in the military world. We've been at war, unfortunately, for 20 years in the aftermath of 9/11, and billions and billions have been spent on shared situational awareness and developing standards to move data seamlessly, and still not doing it perfectly by any stretch, but have made tremendous progress. And some of that rolls over and accrues over into the first responder world as well. But it remains a challenge and something that all of us have to be committed to. Again, vendors and governments and organizations. Often it's the nonprofit organizations, it's the trade groups and so forth that pull together these discussions. Something that certainly is related to this issue of standards and kind of goes back a little bit to the idea of ARVR and XR. There are emerging standards around displaying things in 3 dimensions, right? We are certainly very used to operating in a flat world. We're used to operating in sort of 2 dimensions. 3 dimensions is becoming more and more available, and standards will have to manage how we are able to work with one another on that. But right on the heels of 3D is 4D, right? Which is the X, Y, Z dimensions with time. The ability to play an incident back and forward, the ability to be anticipatory about an incident because we can understand. I'm reminded of the anecdote that, in the early days of Uber, for those of you who remember, you didn't put in a location in terms of your destination. What you articulated was, I through the app, I am here. I would like this type of vehicle, and it became more sophisticated over time. But Uber amassed so much data and information, and through data analytics, that they estimated they were able to know where you were headed in excess of 80% of the time when you requested a car. And this is before there was ever, again, any indication by the rider, a proactive indication where they were headed. So when you think of the power of pulling all that data together, the power of that location data, this idea of 4D, this idea of operating in X, Y, Z, and time, I think gets to something really critically important, certainly something that's happening in the intelligence world and the Defense Department context, is trying to be anticipatory. We want to act and not react. And those same sorts of decision aids, those same sort of aspirations exist in the first responder community. Anytime that we can better enable a firefighter, an EMS, EMT, a police officer to be able to act instead of react, and data and information enable them in a way that's intuitive, in a way that's rapidly assimilated, then they're going to be better enabled to make good decisions at the point they have to, understanding that they are under pressure and there is a human element and there are many things going on beyond their control. Being able to be anticipatory and provide that level of support to them is critically important. So then I guess what I'd like to talk about at this point is sort of what lies ahead. I talked about some of the things that have existed, talked about some of the enabling technologies. Where are we headed? What comes next? Well, I think, again, we'll see this increased spaceborne architecture, the access to space through less expensive launch, the miniaturization and lowering cost of building satellites and the ability to get them on orbit. We're going to see more and more space supported infrastructure, and the things that we're going to get from space, the diverse sorts of phenomenology we're going to get. We're seeing already wildfire fighting in California and Australia, and supported by spaceborne sensors, as well as military grade remotely piloted aircraft. So we're seeing this military technology move over into the civilian sector. It's supporting analytics for businesses. It's supporting decisions. Certainly we were all captured by the stuck ship a few weeks ago, and every day that we looked on social media, we saw another picture from space that showed us a picture of the stuck ship, and we're able to actually see, well, who did it better, who showed us more detail, who could give us more precision with respect to that. So there is this ongoing new space activity. Again, billions of dollars of investment being put into it, and creating a capability that will increasingly be available, not just to a few national governments, but really down to individuals. And certainly local, tribal, state governments will have increasing access to precision weather and precision electro-optical data and precision synthetic aperture radar data from space, and increasingly capable aircraft. And there's an interesting disruptive activity going on in that world, which is stratospheric balloons, right? So balloons that go up above the weather and are able to carry sensors and get a good picture. You could hire a stratospheric balloon operator to deliver imagery of your locality. They can bring it down. They can put a different sensor on. It can go back up and get a different sort of complementary picture. And they're able to do that and compete pretty favorably with the traditional airborne imagery providers. So lots of interesting things going on with respect to remote sensing. Again, the processing power, the access to GPUs, the changing nature of not having to manage a server within a municipality, within a within a company, but being able to have the access to the sort of processing power and storage that you can access from the cloud. The advent of smart meters in this regard for a utility, being able to get a tremendous amount of data back. And when that data is harnessed, like my previous mention of what Uber was able to do by being able to be very predictive in their modeling, smart sensors, smart meters, on the grid, smart sensors on roads are going to be able to provide a tremendous amount of data and information. Again, with the ability to process it, with the ability to make sense of it, with the ability to make it actionable, we can really, hopefully we'll see some money put into infrastructure, but many of us on this call are dealing with the impact of aging infrastructure across a variety of areas and industry verticals. And in situ sensors can tell us a lot more and allow us, again, to be more proactive with how we deal with that aging infrastructure versus reactive. I think broadband communications will continue to grow. Advanced analytics will continue to be more available. The amount of innovation that I see in the marketplace around people really being able to squeeze information out of data and to data enable enterprises, there's a famous quote many years ago by Carly Fiorina when she was the CEO of Hewlett Packard. She used to say, if Hewlett Packard knew what Hewlett Packard knew, we'd be 10 times more profitable. And I think that goes for many of you, if your locality, your municipality, your tribal organization, your state, your company, if it really was able to harness all its data and really make it work for you, you'd be much more effective and much more efficient. And I think we're really at an inflection point with our ability to do that. And so much of it comes back to the sort of things I described as it relates to geospatial intelligence. So let me stop there. I'd love to see if we have some questions or comments, or if there's people who just wholesale disbelieve everything I've said, whatever.
Yeah, Keith, you covered on a ton of topics and a lot of things related back to this data storage and cloud data storage, right? Because if we're collecting all this data, we've got to put it somewhere. We can't keep it on-prem. So cloud's an extremely trending technology and capability I think all of us are familiar with. But what do you find to be the biggest hurdle in these new data sharing environments?
So I really think it is training and education, Drew. Right, we can always look at the future through the lens, or any problem, frankly, through the lens of people, processes, and technology. When I talk to senior executives at Amazon and Azure and Google, the single biggest frustration I hear from them is that people are using the cloud architecture as if it's a server, in the closet like it used to be. And so they spin it up and they leave it going. And the whole beauty, the whole elegance of the cloud and cloud processing architecture is you have your data sitting there in the cloud. You spin up the processing resources you need to answer a question, to respond to a problem, and then you spin that architecture back down because you're paying for it by the pound. Well, that's only helpful to the bottom line if you're not paying for it 24/7, 365. Right. So what I hear from cloud executives is an ongoing frustration, and they're spending an inordinate amount of resources trying to educate their customers, right? We could have a very jaded view that this is wonderful for them, that people are kind of turning the machine on and letting it run, and the meter's just running. But they know that that's not what's good for them, and they know that's not the business model that to which they aspire. And oh, by the way, the downstream effect, it causes them to overbuild data centers, and that they know that when eventually people start acting more rationally and start getting more clear-eyed about how to manage within a cloud architecture, that they would have created and sustained infrastructure they no longer need. So. The long wandering answer to your short question, I think, Drew, is oddly enough, I would argue, I think it's training and education.
Yeah, which makes a ton of sense. Now, I've got somebody that's taking you up on your challenge to identify something and you can connect it to GIS as a disruptor. So I've got a good one for you. So how can GIS be a disruptor or use as a disruptor for financing 911 systems, like and exercising 911 taxing or grant funding?
Well, look, at the end of the day, what are tax? I mean, come on. I mean, if you're going to challenge me, you got to give me something harder than this.
That's a good one, though.
So I'll take it. I'll take it. It's a good one. Look, it's a good one. Still kind of easy though. So at the end of the day, right? Taxation is based on census taking. It's based on location. It's based on maps. So revenue is created within municipalities by understanding who's living where, what socioeconomic status, and that is all, to me, a geospatial intelligence exercise at its heart. Grant funding, right, is often determined by grantors in terms of looking for underprivileged areas that have been poorly served by other governmental activities. And so non-governmental activities, nonprofits will look to fill a void or fill a gap or react to a problem. And I can tell you that grant makers often have very sophisticated geospatial intelligence platforms and operations to understand, because at the end of the day, having been a nonprofit CEO for a decade, what you want to find is much like a for-profit company is looking for ROI, I was looking almost for IOI, right? I just totally made that up, but impact on investment.
Right.
Where and when can I provide an investment that will create the largest impact for my limited dollars? A company does that, a state does that, a locality does that, but nonprofits do that as well. So I would say that I've talked about it from the top down. I've talked about raising revenue through taxes. I've talked about it through the lens of a grantor. Perhaps this question came, I'll speculate, from someone who is on the other end of this equation, trying to make an argument that they should be able to garner resources. Well, I think that argument is ultimately based in a geospatial intelligence analysis of your community, of your municipality, of your utility, to be able to go to someone at a regulatory level, at a nonprofit, at an NGO, and make the case, and through the lens of a geospatial intelligence analysis, why they should grant to you, why they should support you versus somebody else. And I think it often comes back to a geospatial intelligence analytic product that makes that case.
Right. And I think you're right in a lot of senses there, Keith. And I think the challenge that we have at the local government level is really understanding the significant impact we have as GIS professionals on the communities that we serve, and how to flip that a little bit and put it into a business analytical process to garner funding to support these emerging technologies like NG911, like cloud, fill in the blank ... And it's kind of a new twist for local government GIS professionals to think in that capacity, because we're thinking beyond the map now. We're thinking about the data and what the data actually solves.
Right.
So that's a great question. I love that question because we deal with that a lot. And I've got one more question for you as we run out of time. How do you see machine learning, AI, and IoT really impacting emergency response in the future at any level?
My gosh, again, I'm going to go back to my Uber example. Think about if we were really harnessing all the data and behind 911 calls. Who's calling, when, for what kind of call, for what kind of response time, from where, what are the resources available at any given time of day, who responded, how fast was it resolved, what was the second and third order effect, was there a second alarm? Right? I mean, when you think about all the data that could be harvested out of this, if you fed that into machines, you would sit in a call center, you'd be able to staff your call center precisely because you'd know exactly what times of day things were going to happen. And well, this goes back to years of things like community-based policing and the analytics that we know that New York City has made, the NYPD has made famous, for instance, and CompStat and things like that. But data is our friend now. Data isn't overwhelming. The machines fed with all this raw meat, all this raw material, would inform so much about the composition of a shift of a police department, of paramedics, of a fire department. When can I take risk? When, of course, there's going to be outliers, right? And unfortunately, we have to often staff for the worst case because we don't want to tell a citizen, well, the machines told us there weren't going to be any fires at this time of day because there never have been. So sorry, we didn't get to your house, right? That's not acceptable, sadly. Yet, it's not acceptable. But I think the opportunities are remarkable for feeding this data in, and we're going to find patterns. We're going to find, again, that ability to act instead of react in ways I don't think we could imagine.
Right. I totally agree with you. And as we start getting into NG911 more deeply, I definitely see that becoming a more focused part. As we work on the data now, we'll start getting into the trend setting and trend analysis in the future, and the ability to process data at much higher rates, even at a local level. For sure. Keith, this is all, I love talking to you, man. This is always so much fun.
Well, look, I hope it was interesting, Drew.
Absolutely.
Please, everybody follow me at GeoInter, right? So like I'm all in for this thing. You can certainly track me down on LinkedIn and Twitter. If anyone has questions, you can forward them to Data Mark and to you, Drew.
Absolutely.
I'm happy to follow up in any way I can. I really appreciate the opportunity.
Yeah, thank you so much, Keith. And I'll just echo what Keith said. If anybody wants to connect to Keith, please just Google Keith's name, go to YouTube, watch his videos. He's pretty easy to find, but if you want a direct connect, please reach out to me and let me know, and I'll happily create the introduction between you and Keith. Keith, again, thank you so much for hanging out with us this morning and doing this keynote. I love your perspective on GIS and geospatial, especially geospatial intelligence. I think it's valuable now, it was valuable yesterday, and it will continue to be valuable in the future. So thank you so much.
You're very kind. Have a great week. Thanks again to you and David.
All right, thanks, Keith.